Uh, in this lecture, we'll take up the detailing of one-way continuous slab. So this is the one-way continuous slab detailing what is specified as per SP34. So you'll come across two types of detailing in this. One is a slab which is provided with the bent up bars. So this is A using bent up bars. This is a detailing given for bent up bars. In second one, you'll find that it is using straight bars. So here the straight bars have been used. You'll not find any bent up bars over here. Uh, in the first one, what is done is the bottom bars have been bent near the support and they are taken to the top. They will serve as top reinforcement to take up any negative moment coming on the edges. And in the second one, the bottom reinforcement, which can be reduced near the supports, are curtailed and additional top bars will be provided over there. So for taking the so in the second one, the curtailment is done for the bars, bottom bars, which can be curtailed towards the support because of a reduction in the sagging moment, and in turn, the top additional bars will be placed near the support. So these bars will take care of the hogging moment or the negative moment that will arise at the supports. So in this, either when it is a case of a bent up or a curtailment, the distances at which bent up or curtailment can be done, we can look into that. So if you see at the end support, this is the end support over here, or a edge beam, what is there in the beam, in the slab. So these are the beams which are supporting the slab, and the slab is spanning across these beams. So for the edge beam, the bottom steel can be curtailed within a distance of 0.15 times the first span. Okay, so from measured from the center of the support, 0.15 times the first span. So that is the distance within which we can curtail the bottom steel. So after curtailment, 50% has to be available. That is, this is AST1, that is the steel required at the midspan of the first panel of the slab, or this is the maximum AST in the first panel of the slab. So zero point 0.5 times AST1 has to be available after curtailment. Okay, and same if you look at the top reinforcement, zero point 0.5 AS1. Okay, that is to be provided over here. So every alternate bar we are going to curtail here, and at the same position, the top bar will be provided or placed over there. So we'll come across the bottom bar, which is curtailed, and the top additional bar, which will be placed over here. This is for the end support. And also what you see here is the length to which the top reinforcement has to extend. It is given. So this is measured from the face of the support. So it has to extend to a distance of 0.1 L1. L1 is the first span, effective span of first panel of the slab, 0.1 L1. It is that distance to which it should extend here. Okay, so this is the details at the edge beam or the end support. Now, other than this, you also come across these distribution bars, which will run parallel to the length or the longer span of the slab. Okay, main reinforcement will be parallel to the shorter span of the slab. This is a one-way continuous slab. For that, the main reinforcement will be parallel to the short span. Distribution steel will be parallel to the longer span. Okay, that is one. Now, further, if you come to the interior supports, so at the interior supports, the bottom steel, you can go for curtailing it at a distance of 0.25 L1 or L2. These L1 and L2 are the adjacent spans. Okay, so you will have to consider a factor of 0.25 times the adjacent span when you are going to curtail. Say the steel coming from the first span can be curtailed within a distance of 0.25 L1 measured from the center of the interior support, and same the steel coming from the second span or the interior panel of the slab, that can be curtailed within a distance of 0.25 L2 over here. So this is the curtailment what you can do. Again, 50% has to be available. That is, we can go for curtailment of alternate parts. Now the top reinforcement, when you take up the top reinforcement, so top reinforcement should extend to a distance of 0.3 times the respective span of the slab. So 0.3 L1 or 0.3 L2 for interior panel, 0.3 L1 for the end panel, what is shown here. Okay, the curtailment, what you can do is at a distance of 0.15 L1 or 0.15 L2, that can be stopped within after this distance, not within, after this distance. Okay, so 50% you can stop it over there. So this is what for the interior support is. Now you need to refer to the points from which these distances have been measured. Top reinforcement curtailment points are measured from the base of the support, whereas bottom reinforcement curtailments have been given from the center of the support here. So this is what the detailing requirements will come over here. Now, other than this, you need to also know what is the clear cover requirements. So clear cover, you can have somewhere between 15 and 20 mm, either 15 mm or 20 mm, depending on what is the depth of the slab. If you have a slab of 100 or 125 mm, it is better to go for 15 mm clear cover. For higher depths, say for example 150 mm, you can go for 20 mm clear cover. That actually depends on what is the largest size of your nominal aggregate, maximum size of the nominal aggregate. But you can keep in mind either 15 or 20. Out of these two, anyone you can adopt for the slabs if clear cover is not specified. So these are the requirements. Now we'll take this particular problem, what is given here. Prepare the details of reinforcement for a slab of a hall measuring 12 meter by 8 meter. The slab rests on beams spaced at 3 meters center to center. The details of reinforcement are along the long span, 10 mm diameter bar are provided at a distance of at a spacing of 125 mm center to center. Distribution steel used is 8 mm diameter bars spaced at 150 mm center to center. The beams on which slab is spanning, they are of size 450 by 300 mm. 450 is the depth here and 300 mm is the width. And alternate bars have been curtailed near the support. Materials are M20 and Fe415 grade of steel. M20 concrete and Fe415 grade of steel over here. Okay, so here the span what you have in this particular problem, it is 3 meters. So center to center distance between the beams, that is what is given to us. So here this distance is 3000 mm for our problem what we are dealing with now. Okay, so this is the distance which is 3000 mm, and even the next span is also 3000 mm. Okay, so L1 and L2. So for the problem what is given here is L1 equal to L2, that is equal to 3000 mm here. Okay, then I can go for determining what is the distance. So it is told in the problem itself, alternate parts have been curtailed here. So we need to determine these distances here. So 0.15 times L1, that is 0.15 to 3000, that comes out to be somewhere 450 here. Okay, so this is 450. 0.1 L1, this is 300. These are the distances within which we can curtail the bars, every alternate bars. So top reinforcement should extend to a distance of 300 mm beyond the support face, and bottom steel can be curtailed in a distance of 450 mm. When it enters into this length of 450 mm, it can curtail. The rest bar should extend up to the edge of the support. Okay, and here 0.3, this will come out to be 900 for this particular problem. 0.3 into 3000, so this will be 900. The At the interior support, the top steel will be provided to a length of 900 mm, and alternate bars I can curtail them in this 0.151, which is 450, which comes out to be 450 mm. So I need to calculate these before I prepare the drawings. Then bottom steel curtailment, where I can curtail alternate bars on the bottom side, 0.25 into 3000. Okay, that will be 750 mm from the center of the support. So this is 750 mm. Here also it is 750 mm. Okay, so these are the distances, points of curtailment. This also will come out to be 900 mm, 0.3 into 3000, 900 mm, and this is 450, 0.3 into L2, which is 3000, 0.1 into L2, which is 3000. This will also be 450 mm. Okay, now in our case, this AS1, what is this? This is 10 mm dia at what spacing? 125. So 10 mm dia at 125 mm center to center. 125 center to center. Okay, here what will happen to the spacing after curtailment? When alternate bars are curtailed, you will have 10 dia at 250 center to center. Okay, and this top bars, what you have? So 10 dia at 125 center to center. Okay, that is what is provided. Here also you have 10 dia at 125 center to center. Okay, after this curtailment point, you'll get 10 dia at 250. Okay, whereas within this portion, this here AS2, that is AS2 is also, this is also 10 dia at 125 center to center. Okay, so this is what, this is also 10 dia main steel at 125. Okay, here after curtailment you will have it as 10 dia at 250 center to center. Okay, so these are the points that has to be noted for the detailing of this slab. Okay, now one more is the distribution steel. What do you have? So this is the distribution steel, and distribution steel what I have is, it is given as 8 dia at 150 center to center. No curtailment is done for distribution steel. Top as well as bottom distribution steel, they are 8 dia at 150 mm center to center. So in the cross section, this will be how it appear. This will be the cross section here. Now, along with this, you also need to prepare the plan. Okay, so this is our plan for the reinforcement. So this dotted line, okay, it represents the top bars. Okay, so this is what 10 dia at 125 center to center. Okay, this continuous line is representing a bottom bar. Okay, this is a convention or representation of top and bottom bars. 125 center to center. Okay, so this distance, what was this? This was 0.15 here. Okay, I'll not mark the distance over here in this plan. In section we have shown the details, so that is sufficient. So here also this is 10 dia at 125 center to center. Okay, and that will continue. Okay, so this is what, this is the plan. Now what I have here, the center to center distance I have been mentioned for us. So this is 3000. Okay, and this is also 3000 mm, and 3000 mm, and same here 3000. So 12 meter by 8 meter. Okay, so this is 8000 mm. Okay, so that is the room size, 12 meter by 8 meter overall, and center to center distance between the beams was given as 3 meter center to center. Okay, and here this beam, okay, this is the width of the beam, it is mentioned to us here. Okay, so that can be shown here. No reinforcement detailing of beam is required, we are only dealing with the slab reinforcement detailing. Okay, so with that, just to plot it in AutoCAD, right? So what we'll do is we'll begin with that section. So I need a rectangular section here. First edge 0, 0. I'll start with that one. And the second edge, thickness of slab, it was mentioned or no? Okay, slab thickness, okay, not mentioned. Let me put it here. $115. That is the thickness of the slab. So what will happen here to my next corner is 12,000. That is length and 115 depth of the slab. This is a cross section what I am drawing here. So this is my slab, right? So on this, we'll now go for representing the beams. Okay. So beam size. What is the beam size? I had it as 450 by 300. Width is 450. So 0, 0. Width is 300, comma 450. So this is our beam. So beam, it will be including the thickness of slab here. So this is came out this one. Okay, now I have this beam. And also done. Now these are spaced at what? 3 meters center to center. Okay, so I'll take it to 3001. Next will be 6000. Next 9000. And then 12, 1, 2, 3, 12,000. So this is the spacing of the beam. So this will be using this 12,000 edge beam. So it will be flush with this end of the slab. Okay, and since this beam and slab, they are cast monolithically, so I should not be having this line over here. So this is gone. Yeah. So this is the cross section of our slab. Now in this, what we require is to show the reinforcement. So I'll take this one. Okay. Let us take a line over here. Then from this end to this end. Okay. And at the end you have a cover provided here. Okay, so what I need to do is move this one by cover. I'll take cover to be 15 mm. I'll move it by 15 mm. Okay, and the side cover also is there. Let's say you can provide it some 25, just convenient. So right, so this is the bottom reinforcement. This line is representing the bottom reinforcement. I'll make it a little bit thicker than other edges. Okay, so we'll normally increase the weightage of these lines. I want the reinforcing bars to appear thicker than other edges, other component edges. Okay, for that purpose, I'm just showing this thickness over here. So this is our reinforcing bar. Okay. So 0.25, let it be 0.25, even if it is not appearing properly, but I'll keep it 0.25. Now what I need to do is, I need to show the curtailment points there. Okay, so edge curtailment, what is the edge curtailment? It was 0.15 times the first span, 0.15 L1. Okay, so this I am marking this 1450. Okay, so 450. Okay, so this is the point where our first curtailment will be coming. Okay, within this distance, when our bottom steel comes within this distance of 450 mm, I can go for curtailment, or exactly at the distance of 450 mm. Where is that? Okay, so this is the point where you have to curtail the bar. So how do you show the curtailment? Just by one kink in this line, like this. This represents that curtailment has been done. Same on the other edge over here. That is the other end. So this is minus, sorry, just 450. So this is the point, and I require this to be curtailed over here. Okay, so with the two supports curtailment I've shown here, now I'll move to the interior support. For interior support, bottom steel is referred with respect to the center of the support here. Okay, so what was that? 0.25. So it was 750, 750 on either side. So here what I require is from this point, it is from the center of the support. So from the center of the support, 750. Okay, and the same on the other side. This is all for construction purpose. Okay, I'll be taking out these later, which are not required lines. Okay, so this is point on my curtailment. Should be on this side from the interior support, on the interior panel. Here from the interior panel, it will be coming like this. Okay, so these are our curtailment at the interior support, bottom steel curtailment at the interior support. Okay, so same has to be done for other interior support. I'll just copy these marks with the center as my base point, paste it for the support. Okay, and for the other support also. Done. So we have shown the curtailment of the bars for bottom steel. It is both end support as well as other interior support has been done here. Now for the top bars, what I have on the top side. So here from the face of the support, okay, the bar has to extend. Okay, so to what distance it should extend from the face of the support? It has to go up to a distance of 0.1 L1, that was coming out to be 300 mm from the face of the support. Okay, this was for end span, so 0.1 L1, that is 300. So I've taken a line from the face of the support for a distance of 0.1 L1. Okay, so let's where it has to be. So here, done. But I require that cover, so I'll just move it below this one by 15 mm, right? And it should be extended. Let's use this extend command. So here, choose that command, right click anywhere in the space, you'll get that. So this is my top reinforcement. I can stop that top reinforcement at a distance of 0.1 L1 from the face of the support. So from face of support, 300 mm, 0.1 L1. Okay, so same is required on the other side of the slab at the one more end. Okay, do that, you just copy this line. Okay, so from this edge, done. So that is the top reinforcement at the exterior end support or the HB. Now coming to the interior of the span, what I have 0.3 L1 or L2. Since in my case L1 L2 are same, they are coming out to be 0.3 into 3000 mm, which is 900 mm. So 900 on either side of my support here. So what I have from the face of the support, I require a distance of 900. Okay, so this is 900. Okay, so not this one, it should be from the face of the support. Okay, and same on the other side. It is left to you which command and how you are going to use them. So this line is now my top reinforcement at the interior span. I just move it, take it to the top and provide this cover space gap. Move from here 15 mm cover. Okay, so what is happening here? Curtailment is also there. At what point? At a distance of 0.15, right? So 0.15 L1 or 0.15 L2, which is coming out to be 450 mm. Okay, so I need to show that 450 from the face of the support, 450, and again from this end, what I have here, 450. Okay, so I'll show this curtailment points over here. And so these are the curtailment points. So I'll be curtailing the bars over here. So same for the rest of the interior support. I'll just copy this one. For this, I'll take this center of support as base point. So here 1 and this is 2. So we have that reinforcement. Now distribution steel, I have to show the distribution steel. So draw this donut. Inside diameter 0 and outside diameter, let's take 10. That should be sufficient. Okay, this is enough. And this, what I have, total span is 12,000. Distribution steel is based at 12,000 divided by spacing of distribution steel. I think 150 mm was spacing. So here it is 150 mm center to center. At 150 mm center to center. So this I require 80 columns. So array, rectangular array, rows will be 80, row offset 150. Sorry, columns will be 80, rows will be 1. Column offset is 150, row offset is 0. Okay, so here is our distribution steel. Okay, so it is placed over here. Done. Then on the top also we require the distribution steel. So what we'll do, we'll just take these itself, copy them for this top. Maybe 1.5 minus 1500. Let's try another method. What is this distance actually? If I have this from here to here is 985. 85 minus bar dia 10, so it should be 75. And copy them and paste them at a distance of 75 mm in vertical direction. 75, yes. So this is here, right? We are having a distribution steel for this top reinforcement also. Same, I need it for one more this one here. There is that endpoint here at the other support. Let's leave it over here. Fine. And the same for this one. For the interior support also, on the bottom side of top reinforcement, you will have the distribution steel. So just select these, copy them by what distance? 75. Okay, so these are additional lines. Right. This one. Okay. Yeah. Done. And same will be there for our other interior support also. Okay. We can just copy this entire thing also. No problem. Here and here. Okay. Let's choose these, only these. This reference and here, okay, and over here, right, okay, done. Hmm. So we have the distribution scheme, what we have. Fine. Now coming to the detailing part. So first is the dimensioning. So I'll just change this dimension style, increase the font size here, modify this one, text size. We'll make it as 50. And as text, what we'll use, Arial. Okay, plus and set current. Right. So linear dimensioning. This is the center distance between the supports. And again from here till here. Then dimension linear from this end to the center. From the center to this end. Okay. Fine. Then for one more span, dimension linear from here to here. Yes, set. So these are the dimensions. And one more, what I have to do is curtailment points. Linear dimension. So for this, it is measured from the center of the support till this point. this should be 600. It has to be 450. So I have it as 450.15 into 3000. It should be 450. So just take it, move by 150. Yes, 450. Same for this end. This is also not correct. So this is 150 dimension here till the center of the support. That is 450. Now the top one, it is measured from the face of the support. Linear dimensioning, so measured from this face up till end of this bar. This is 0.1 L1 300 mm. That is correct. No problem with that one. Same for this side from face up till end of this bar. So this is 300. Okay. And for interior, what we have, bottom steel measured from the center of the support. So this distance, so that is 750. That is 0.25. Again from here center till this 750. Okay. Top over here from the face. This is 0.3. It should be 900. This is 900. And my first curtailment point is 0.15, 450. Let me check 0.15. Okay. Same for this also from face till here. It is 900. And from face till the curtailment point, it is 450. Okay. So I'll just copy this dimension for the rest of other support also. Center of support as my base point. Copy here and here also. Finish. So this is the dimension. Okay. So once that is done, we'll go for detailing, and I require this leader. This is what this is my main reinforcement. So here 10 at 10 at 125 center to center. I'll put this symbol. What is the symbol? Diameter. Okay, diameter symbol. Fine, this is okay. We'll increase this arrow size. Dimension style 45. So arrow size, where is this? Arrow size 20, 25. 25. Set current goes fine. Little bit more. Dimension style and modify this one. Arrow size will make it 50 itself, same as text height. Fine. This is okay for me. One detailing. Same is there for other interior span as well as the top bars. So this will copy it. These objects. Enter. So base point. For the next interior span also same thing. Here also same. Okay, and on the last span. That, okay, 10 diode, 125 center to center. Okay, so bar diameters, bottom steel we have shown for main steel. Same for the distribution steel. Before that, after curtailment, we require it. So now it is becoming 250 double, 125 to 250 after curtailment. So where else I require this one? Somewhere here, inside the support, and here, as well as at the end support. So that is after curtailment. Diameter. Okay, this is fine. So bottom steel, we are done the detailing, and top steel we need to provide that one over here. So for this end one, we have this as a top steel. So this will entirely extend to a distance of point. What we have 10 at 125. The symbol is coming here. I'm not 125 center to center. Okay. So is this is diameter. Top steel. Same I require for other at other supports. Okay. So here. Okay. And after curtailment, what we have, this is delete. This will become 250. Okay. this one, this point, and one, and other one this and near. Right. So this is enough. Top and bottom reinforcement detailing is done here now. The only thing is to draw the plan. So again, for that we will go with this rectangle 0 0. What we have is 12,000 comma 8,000 for the plan of that slab. This is the plan of the slab. It should be coming somewhere here. So P, this is 300 mm width. Okay, so since these lines are hidden, we'll show them as a discontinuous line. We choose this one. Okay, lowest scale factor, let it be 100. Okay, done. Okay, then for this at a distance of 3 meters. So offset this one. Okay, and then by 300. Let me check this center to center distance. So 3 meter. Take this by, move this one by 300 mm. Now it should be okay. Center to center distance will be 3 meters. So this set entirely will copy it. And what length it has taken here from here till here. It is okay, 12,000. Move this by 600. So this is the plan. These are the beams what you are seeing now. In this, the top bar. Okay, this is the top bar here, and the top bar is shown by a discontinuous line here. I'll choose another one. So first one, okay. this is the top bar. So in the center also I require a top bar. So it is 900 plus 900, 1800 and 300, 2100 total length. So this should be of length, or you can just copy these bars, change them over there. This is the best way you can do. Since these are top steel, show them by a discontinuous line. So now the bottom steel will be appearing as a continuous line here. So this is our one of the bottom steel. So here one more we can show. So these continuous lines are representing the bottom steel, and these continuous lines, they are representing the top steel. Something like this. And what I require here is this distribution bar. And distribution bar, they are 8 bars shown here. So these are 8 dial at 150 center to center. Okay, so they are sir. Okay, so this is distribution steel, detailing plan. And, this is okay done. And this is what, this is our fine. This is the distribution steel. that is it, plan and section. While taking print, you may have to choose this one scale for this, okay, so that it appears clearly. Okay. Uh, this is okay, fine. Okay. And somewhere here, thickness has to be given. 115 THK. That indicates thickness of the slab. And in the node, grade of concrete M20, cover 15 mm, and especially most important is all dimensions are in mm.